Welcome to the video on limits and infinity, part 1. In this video we're going to talk about the basic technique for solving limits and infinity, and then we're going to solve one example step by step. So first of all, what are limits and infinity? Limits and infinity are just like normal limits. The difference is that x is approaching infinity instead of a number. And the notation we use is this one. We read this as the limit as x approaches infinity of f of x. This is how it is read. And what this means is that x is ground without bounds. That's what x approaches infinity means. Or another way to think about this is to say that x is taking values greater than any number it can come out with. So let's talk about how to solve these limits. And the neat thing about limits and infinity is that there is a single basic technique that you can use for almost any limit and infinity. And it has several steps. The first one is to find the greatest exponent in the function. For example, let's say that we have this function. We want to calculate the limit of this function, and we want to find. And the first thing we need to do is to find the greatest exponent. Here we have x squared. Here we don't have an x, so the exponent is 0. Here the exponent is 2. Here we have another exponent 2, and here we have exponent 1. So the greatest exponent here is 2. Step 2 is to divide both the numerator and denominator by x to the n. Here n is the greatest exponent we just found in the previous step. So in this example we must do this. We divide everything by x squared. That is, we divide the numerator and we divide the denominator. Remember that we can't do this without changing the value of the expression. And step 3 is to simplify the expression. For example, in this case we can separate the fraction like this. Whenever you have 2 or more terms in the numerator and only one term in the denominator, you can do this. We do this in the numerator and the denominator, and we can cancel the x squared here. We cancel the x squared here. We can cancel x, and we get this expression. And step 4 is to calculate the limit using the last expression we got. And we're going to do that in this example. Here we have the limit as x approaches infinity of this function. It is the quotient between two polynomials. So the first step is to find the greatest exponent. In this case we have x cubed here, and that's the greatest exponent. The greatest exponent is 3. So we divide everything by x cubed. We divide each term by x cubed. We get this, and we can start simplifying things with, for example, this x cubed here, the x squared here, the x cubed here, and we get this expression. Now we can calculate the limit of this function. How do we do that? We can observe that anything that is divided by x will approach 0. Why is that? Because x is approaching infinity. And you can test this with your calculator. If you select any number and then you divide it by a very big number, much bigger number, you get something very close to 0. That means that anything that is divided by a very big number will approach 0. So, for example, it means that this term here will approach 0. This term also will approach 0, and this term also will approach 0. So the limit of this function is 4 over 5, because everything else becomes 0. And the limit of a constant is a constant, 4 over 5. And that's the final answer. So that was just the first example of limit and infinity. and in the following videos we're going to solve more limits using this basic technique, and then I'm going to introduce other techniques for solving these limits. So that's all for now. Thank you for watching, and see you next time.